Okay, welcome to Let's Get to the Marks. This is an amino acid question from 2022, paper 2. Question 4. Proteins are polymers made from amino acids. Part of the structure of a protein is shown. We've got cis, asp, and fer. These are abbreviations for amino acid names. Each amino acid in the protein is shown using the first three letters of its name. Identify the type of protein structure shown. So we have three possible answers, which are primary, secondary, and tertiary. The primary is the amino acid sequence. The secondary is the first level of folding. You've got beta-pleated sheets or alpha helix. And then you've got the tertiary structure. Oh my gosh, I can't spell. Or 3D structure. Okay, you can see there what we're shown is a linear line of amino acids. It is the amino acid sequence, the sequence or order of the different amino acids. And that's the first answer, the primary structure. Now we're on 4.2. Draw a structure for the cis-ser section of the protein. Use the data book to help you answer this question. So now we need to flick to the data book and see if we can answer the question. So here's the data book, and you can see there's the structure of cysteine and there's the structure of serine. So I've circled those. Those two structures I'm going to draw out and then work out how they bond together. So this isn't going to score you any of the marks, but what I'm going to do now is draw out those structures. So the first one I'm going to draw out, okay, I'm just copying it down from the data book. I'm going to do this in a different color. And this is cysteine, which has the sulfur atom on it, on its R group. And the next one we're going to draw out is serine. It doesn't have the sulfur atom, but I'm going to draw this in blue because it's going to help us identify what's happening with the different atoms when these two join. Now, of course, they're going to join to form a dipeptide, but they could form a giant polymer, a polypeptide, by just joining end to end and end to end. And they form in condensation polymerization. And of course, condensation refers to the water molecule that's formed when two amino acids join together. So we're going to lose the hydrogen off the amino group and the OH off the carboxylic acid. And of course, you have to remember, which people don't, if you're doing a polymer rather than a dipeptide, then you lose another OH off the amino acid and another H off of the amine group. So it goes on and on and on. So for every two amino acids that join together, you get two H2O molecules produced. All right, let's join them together now that they are joined. So I'm redrawing these minus the atoms that I've circled above. You get no marks for the drawing I've originally done there of cysteine and serine. This is me just showing you the working out. But what we're going to do here is show the peptide link with the carbonyl bond and the NH bond joined together in the middle there. And we've lost the OH and the H from the middle. And don't forget, for your trailing ends, they're the lines that come out the brackets at either side. For your trailing ends, you need to remove an OH from the carboxyl group and an H from the amino group. And that is the answer. You can see it right there. That is what is formed when a cysteine and serine join together. And it's that that will get you the 2 marks. Don't worry about the water molecule or the bit above this. That was just working out. Okay, 4.3. Name the other substance formed when two amino acids react together to form part of a protein chain. So we just saw that from my drawing before. You get a water molecule being released, and remember you get 2 water molecules, one from the middle and then one from either end, where you've got the other peptide chain, bonds forming. Right, the general structure of amino acid is shown. H2NCHCOOH with an R group. R represents a group that varies between different amino acids. R groups can interact and contribute to protein structure. 4.4. Explain why the strength of the interaction between two R groups differs from the strength of interaction between a serine R group and an aspartic acid R group. So we're going to go back to our data book here. So we go back to our data group and identify cysteine with the sulfur atom attached, and we've got the aspartic acid with the 2 carboxylic acids. The carboxylic acid is on the R group as well as the normal. So now we just want to look at why the strength of interaction between the two cysteine groups is different than the strength of interaction between the R groups on the aspartic acid. Now remember, the cysteine groups have these sulfur atoms, and what I've drawn here is a disulfide bridge that is across the middle. So now I'm going to draw the interaction between the two R groups on aspartic acid. Now remember, aspartic acid has an R group with a carboxylic acid on it. It has the carboxylic group in the normal amino acid structure, but in the R group it has an extra one. And what we have going on here is we have hydrogen bonding. So remember, oxygen is delta negative or partially negative, and the hydrogens are partially positive. And so what that results in is hydrogen bonding. So now we know that the aspartic acid has hydrogen bonding and the cysteine groups form disulfide bridges. We have to ask ourselves, which one is stronger? Well, cysteine groups form strong disulfide bridges. Now, disulfide bridges are a covalent bond of shared electrons. So you've got those strong electrostatic forces of attraction between nuclei and pairs of shared electrons. And that is going to be a lot stronger than the intermolecular force, that is hydrogen bonding, that we get formed in aspartic acid between the R groups. Okay, so really this is a 4 marker. You're going to get 1 mark for acknowledging that cysteine groups form disulfide bridges, 1 mark for acknowledging that disulfide bridges are covalent bonds, 1 mark for saying covalent bonds are stronger than hydrogen bonds formed in the aspartic acid groups. And that's your 4 marks. Boom. Sorry about my voice on today's video. There's something up with my audio. It's coming out like a robot. So we have 4.5. Deduce the type of interaction that occurs between a lysine R group and an aspartic acid R group. We need to go back to our data book and check it out. So if you look, we have aspartic acid. This has got the carboxylic acids, and lysine over here has got an amine group on the R group. So we've now got the interaction between a carboxylic acid and an amine group. Now let's have a little look at what goes on there. So I'm drawing out the amine group and the carboxylic group on the lysine and aspartic acid R groups that interact. What happens is one of the hydrogen ducks over to the amino group, making it have a positive charge, and the carboxylic acid ends up a carboxylate ion with a negative charge. And of course, positive and negative charge, these aren't partial. This forms ionic bonding. And that's your lot. So subscribe, hit the like, let's get to the marks.
You're still here? It's over.